Let's practice completing the squares of some quadratics. Solve for x by completing the square. See if you can do this one on your own. Okay, first we take our coefficient of x. In this equation, that would be 4. We divide this by 2 and square it. 2 squared is 4. Now, we add this value to both sides, giving us x squared plus 4x plus 4 equals negative 3 plus 4. Negative 3 plus 4 is 1. And now, to complete the square, we know that the completed square on the left will just be x plus the coefficient divided by 2 squared. Our coefficient is 4, so this gives us x plus 2 squared. Now to solve for x, we need to isolate. To begin, we take the square root of both sides, the square root of a square cancels out, and the square root of 1 can be written as both negative 1 and 1, since both negative 1 and 1 squared is 1. So we have x plus 2 equals plus minus 1. Subtract 2 from both sides and we get negative 2 plus minus 1. Now we can simplify this. Negative 2 plus 1 is negative 1, and negative 2 minus 1 is negative 3. Thus the answer is negative 1 and negative 3. Okay, let's try another one. See if you can solve for x in this quadratic by completing the square. Alright, so the first thing we need to do here is get x by itself. We can do this by adding 9 to both sides. Thus we get x squared plus 5x equals 9. Now, to complete the square, we add half the coefficient of x squared to both sides. In this example, that would be 5 over 2 squared, which is 25 over 4. Now, we can complete the square, knowing that the left will just simplify to x plus 5 over 2 squared. To simplify on the right, we can write 9 as 36 over 4 to get a common denominator, and 36 plus 25 is 61. So that would be 61 over 4. So now, what is x? To solve for x, we take the square root of both sides. The square root of a square is just the number inside, and on the right, taking both the positive and negative roots, we get x plus 5 over 2 equals plus minus the square root of 61 over 4. Now to isolate for x, we subtract 5 over 2 from both sides. This gives us both negative 5 over 2 plus the square root of 61 over 4 and negative 5 over 2 minus the square root of 61 over 4. And now we can simplify a little bit. We know that the square root of a fraction is the square root of the numerator over the square root of the denominator. Thus we can simplify the square root of 4 as 2, and that's as simple an answer as we can get. Let's try one more. Solve for x in this quadratic by completing the square. This one deals with fractions, but you can do it. Give it a shot. Alright, so in this example, x is already isolated for us. So now let's complete the square. What is half the coefficient of x? Well, 5 over 6 times 1/2 is 5 over 12. Now we square this and we get 25 over 144. And now we add this to both sides of the equation. On the right, to write negative 1 over 6 with a common denominator, we'll have to multiply by 24 over 24. This gives us negative 24 over 144 plus 25 over 144. Adding the numerator, we get 1 over 44. And on the left, we know that the quadratic can be rewritten as x plus half our coefficient squared. This is x plus 5 over 12 squared. And we've completed the square. So now we can solve for x. If we take the square root of both sides, the left becomes x plus 5 over 12. And on the right, the square root of 1 over 144 can be both 1 over 12 and negative 1 over 12. So this gives us x plus 5 over 12 equals plus minus 1 over 12. To isolate x, we subtract 5 over 12 from both sides, and this means x equals negative 5 over 12 plus minus 1 over 12. And to simplify here, negative 5 over 12 plus 1 over 12 is negative 4 over 12, which simplifies to negative 1/3. And negative 5 over 12 minus negative 1 over 12 is negative 6 over 12, which is negative 1/2. Thus our roots for this quadratic are negative 1/3 and negative 1/2. Awesome job. And that's how you solve quadratics by completing the square. If you enjoyed this or learned something, don't forget to like and subscribe and share it with a friend. Now, keep working hard and keep learning. Thank you for watching.